Chapter 8: Sampling Distribution and Central Limit Theorem. The sampling distribution is the probability distribution of a sample statistic. That means if we have a population, we take samples of size n, for example n1, n2 and so on, and we calculate the mean for every sample, x1 bar, x2 bar and so on. So these means are going to follow the normal distribution. These are the two properties of sampling distribution of sample means. The mean of the sample means, we call it mu x bar, is equal to the population mean, and the standard deviation of the sample means, sigma x bar, is equal to the population standard deviation over the square root of n. So sigma x bar is equal to sigma over square root of n. From now on, the standard deviation of the sample means, we will call it the standard error of the mean. The central limit theorem says that if we have any population with a mean of mu and a standard deviation of sigma, we want to have a large sample. N has to be greater or equal than 30, and this is for any population, in order the sampling distributions of the sample means to follow the normal distribution. And actually, the greater the sample size, the better the approximation. So keep in mind, for any population we need a large sample size, n to be greater or equal than 30. However, if the population by itself follows the normal distribution, then no matter what is the sample size, the sampling distribution of the sample means is normally distributed. So in this case, you don't have to worry about the sample size. You can have a small sample size, 10 or 15. Let's go to see example number 1. For example number 1, we have the population mean. We know the standard deviation is 9, and then the sample size is 36, so random samples of 36. So in this case, we look for the mean and the standard error. So the mean is equal to the population mean, is equal to 64, and the standard error will be 9 over square root of 36. And then, since we have large sample, n is greater or equal than 30, then it will follow the normal distribution. Let's go to see the solution. In this case, the mean of the sampling distribution is equal to the population mean. So mu x bar is equal to mu is equal to 64, and the standard error is equal to sigma over square root of n. That means 9 over 6. 6 is equal to the square root of 36. So 9 over 6, 1.5. And again, because the sample size is greater than 30, the sampling distribution can be approximated by a normal distribution with a mean of 64 and a standard error of 1.5. Example number 2, we know again the mean, we know the standard deviation, we have a small size of 4, but we know from the problem that the population is normally distributed, so we don't have to worry about the sample size. So again, mu x bar is equal to mu is equal to 90, and sigma x bar is equal to sigma over square root of n, 3.5 over 2, 1.75. And since the population follows the normal distribution, the sampling distribution of the sample means is also normally distributed, with a mean of 90 and a standard error of 1.75. Now, the z-score on the previous chapter it was x minus mu over sigma. Now it will be x bar instead of x, mu x bar, which is equal to mu x bar is the same as the mu, and the standard error is sigma over square root of n. So in the reality, compared to the previous formula, we have to divide now by square root of n, Let's go to see example number 1. We know the mean, we know the standard deviation, and also we know the sample size. So what is the probability that the average credit card holder has a balance of less than 2500? So step 1, we calculate the z-score, and now this is the new formula. 2500 minus 2870 over 900 over square root of 25. Calculate the numerator, calculate the denominator, and then divide. So the answer is negative 2.055. So we go to the closest one, negative 2.06. So let's go to the table of the normal distribution. So 2.06, this is 2.0, 2.06. So here it is, 0.4803, 0.4803. So this is the probability between 2500 to 2870. So you look for less than 2500, so you have to subtract from 0.5. So the answer is 0.0197, 0.0197. Example number 2, we know the mean, it is 8, the standard deviation is 0.7, and we have a sample of 38. So what is the probability that the mean height is less than 7.8? Again, we calculate the z-score. The z-score is negative 1.76, negative 1.76. 7.8 minus 8 over 0.7 over square root of 38. So for negative 1.76, the probability will be 0.4608. And again you look for a tail, so you subtract from 0.5. So the probability will be 0.5 minus 0.4608, 0.0392, 0.0392. Last problem, the mean is 34,000, the standard deviation is 2500, and the sample size is 50. So we calculate the z-score, and it is equal to 2.83. So one more time, this is the probability between 34,000 to 35,000. So for 2.83, this is 2.8, the probability is 0.4977, 0.4977, and then since we have a tail, a right tail, we subtract from 0.5. So the answer will be 0.0023.